I wanted to start part two with a topic that we found quite difficult to really figure out how to get the right API for 1.3. A lot of community discussion about how much of this should be standard Go API, how much of it did we really need to be managing in our own particular way. This is file handling. It's the oldest thing that many apps will have been doing, but there are many reasons why the standard os.file isn't necessarily the right fit, and how you can avoid cross-platform headaches by following a few simple practices. So yeah, file handling, cross-platform I/O. Why is it so difficult? We'll cover that in just a moment. We'll look at using the file dialogues that we mentioned earlier in the 1.3 release to open your files into an application. And we'll talk about saving two files through user-selected output in a file dialog as well. We'll also discuss how to access files directly. So that is not wishing for the user to have to choose a file, but you know where you're looking to access data from or write to. We'll talk about that. And we'll cover the URI type that was introduced as part of these changes and how to manage data sources. And wrap up with a little selection of things to remember when managing files in your application that should hopefully get your application to be as portable as possible so you can take advantage of the cross-platform capabilities of Fyne. So yeah, let's think for a minute. Why is this so difficult? Well, to start with, not all of the standard file operations are possible on all systems. There are a number of protected areas, for example, across certain systems. You might find that permissions vary. There are even platforms that require you access specific privileges to read any files, not just system protected files that you might be familiar with on your desktop. Different file systems and operating systems have different ways of addressing files. We all know this, but it does impact portability if you aren't entirely certain what sort of address system will be used on the runtime when you're writing your application. Like I mentioned, there's permission issues sometimes relating to systems or specific directories. Anybody who has used a recent version of macOS will be familiar with this application wants to access your downloads folder, or if you have developed a mobile application, you'll probably be aware that having a pointer to a file, a handle to a file object, isn't enough to read from it. You need to say, I would like to be accessing this external resource. And also, especially on mobile and embedded platforms, not all data sources are going to be files. Now, of course, there's plenty of data that we understand, data streams, byte streams, remote resources that we're used to managing without file pointers. But on a native mobile file picker, perhaps, you could be being returned what the user thinks is a file, but actually it's not. It's a bundle of data, it's a content that has come from some other resource, some application that you had installed elsewhere that knows how to deliver that sort of data to other applications. So that's why it's difficult. You know, there's all sorts of things to bear in mind, but as with everything else, the Fyne toolkit wants to make sure that you don't have to worry about that in your applications. So we've introduced a selection of new APIs that are going to help that. Let's start with opening a file using the dialog that was shown at the beginning of the first part of this presentation. Show file open. It's a standard dialog API. It fits with other dialogues. You call that, it will create the dialog for you and then show it to the user in the current window, the window that you specify as the last parameter to this call. The function that you're passing in to the file open is going to return, or rather it was going to call the function when the user returns from the dialog, and it's going to provide information to you that is either a handle to a URI read closer. This represents the source of the data that the user has just selected, or an error. In the standard way, we would check that the error is not nil before proceeding. If it is, you probably need to do something according to the context and the expected user intent at that time. The code illustrated here is just taken from our Fyne demo app, and if there is an error, it shows the error. It's the easiest thing to do in a demo application. If there was no error, we're going to call file open with that URI read closer, and we'll talk more about that next. This is, I think, a pretty straightforward way of asking for the user to choose a file, but the complications probably are in this read closer. Now, there are certain pieces of functionality available. A URI read closer is like a read closer standard Go, which a file, an os.file, is also a read closer. But we are using URIs under the hood to uniquely identify a file or a data source. So the read closer has a URI method that is going to return to you the URI that it represents. And on that, we can call things like extension and name. So this code snippet here is illustrating that if we have been given a text file, then we would like to read all of the data out of that file. The data is clearly here saved in the data variable. Also, we have an error again. It's possible that the read doesn't succeed. The user could have picked data that either is not accessible, maybe it's been removed, or any number of other possible things that could have happened that mean that that data can't be accessed. So be sure to always check that error. And also make sure that you close the URI read closer. It must always be closed whether or not you read the data, because it's holding open a native file resource. So make sure that you close it. So that's how we can access data from the user's system that they have chosen. How do we write data out to a selected location? Well, again, we have a dialog that we can use. Show file save is the write equivalent of the read operation, show file open. You can see the code here is very similar. We will be called back when the user makes a selection. They're providing to this callback a write closer and a possible error. Again, check the error, and then we'll handle the details of what to do with that reference in another method that we've called file save. So how do we work with this write closer? Well, there shouldn't be any particular surprises here. We're going to be able to write to it using the standard tools in the Go library. Here, we're illustrating with write string. So the contents of the formatted string wrote file at URI and then the result of the URI are written into the location that the user has selected. Of course, here the error accidentally hasn't been checked. You definitely should check the error, but also you definitely need to be closing that URI write closer when you're done. You can see here we've not included any particular reference to be printing in the formatted string, and that's because URI implements a stringer, so it's going to format nicely for you. Just a little helpful thing if you're debugging around this area. So that's how we can work with files when the user is making their selection, but that's not always going to be the way that we want to go. It's often going to be needed to access files directly. Now, we're not talking about embedded or bundled resources, the type of thing that an application is going to use as part of its runtime, but user content, something that's stored external to the application. So you probably were given a URI before. If you imagine a recent files list, for example, you would be aware of when a user makes a selection to open a file. You want to be able to access it later if the user tells you to perform that action. You certainly don't want to force them to go through a selection dialog again. So to do this, we can save the URI for using later. Its ID is stored internally and can be accessed using the string method. Now, this is part of the stringer, and when printing out will automatically be called. But if you're making the selection to be saved, it's a good idea to be very specific about what you're looking for. that's going to save the string representation of the ID. This can be persisted like any other user data, part of your application or document in memory or to the file system. Later, you can use this URI to create, you can use this ID to create a new in-memory URI that can be used in part of this API. There's a new package here called storage, which has a lot of functionality for handling input, output, and file management that we're talking through just now. New URI is taking this unique identifier that you have stored and creating a URI object in memory that you can then use some more advanced functionality on. So we have a cross-platform reference now with a bit of functionality. So we can use this to open or save files without using the file dialog. Again, the storage package is key here. We have open file from URI and save file to URI. And these are going to return to you the same type URI read closer or URI write closer, so that you can work in the same way as when the user selected the file. It's quite helpful actually that you can use the same code. It's really just a case of how the selection of where you are getting your data from was handled. So that's how we can access files, how we can have the user select the files to work with. But let's look at what URI types are. What are the data sources that we're talking about here? I mean, it's files, obviously. I mean, that's what we want to access. We can see on the left there, we have a traditional Unix or Linux file descriptor. It's prefixed with file : // and then you have / for the root, a home directory for the user, a directory within that, and a file name. And that might be familiar to a lot of developers who prefer the Linux system or Mac OS. But if you're on Windows, you're going to have something that looks a little bit different. It's going to have a drive letter squashed in there as well. So we need to be aware not to take too many things for granted when we're handling URIs. The file path that you see embedded in some of them might not be exactly what you're expecting. However, it might not be a file at all. A file picker could indeed return something more like this, a content-based URI. This is something that you probably see a lot on Android if you've been developing apps there, or even if you've been running your Fyne apps in Android using these new APIs. The data that you are being returned might be identified by the application it came from and the resource identifier internally. That might look like a file if it is perhaps a file-based application, but it could also be automatically generated. The thing that you can be pretty sure about is that it's going to be a unique ID for that resource. So you can, like before, save that URI for accessing later. But when you do use it later in your application, be sure to check those error returns, because it's entirely possible that that application might have decided that that data is no longer available. It might not be available to you. You may need to say to the user that content is no longer available and display perhaps the file picker again so they can choose an alternative location. Now these are types that you would see if you work on a Fyne application right now, but it's possible that we could be doing any number of other things as well. As the toolkit moves on, we're not limiting to local files and local data. We could be talking about remote resources as well. An HTTP resource across the web, you might be looking up something across a file transfer protocol or an SSH mounted home directory. There's all sorts of possibilities here. We're going to try to keep access to this data readily available under standard APIs so that users have a straightforward interaction no matter where the data is coming from. And the more that your applications can do to step away from the assumption that files can be addressed with a string file path, the more that your applications are going to be portable across systems. So that's the big picture things, how you can work with files and whether it's user selection or stored for later. What is it that the takeaways are, I suppose? when you're managing cross-platform file resources? Well, I'm going to say it again because it's really, really important. The data returned may not come from a file. And even if it does, the URI to that file might not be a file : / prefix. So don't make the false assumption, find the URI returned from the picker, and then use the string with a bit of manipulation to take file off the front and use the standard file IO. It's probably not going to work when you start looking across other platforms. Now that said, if you're in complete control of the runtime environment and you know that these accessed resources are always going to be files, you might choose to do things a little bit differently. But bear in mind what I mentioned earlier, that the Fyne toolkit is not promising that what you get from a file picker will be a traditional file. So it's probably unadvisable to make that assumption. Always check the errors. I am one of those people, as you might have seen in the live code, that we just ignore an error here if we're doing a demo or if we're trying to put together an application quickly. That error is probably not going to happen, or it might not be a problem if it does. In these situations, you're probably following on from a user-initiated action. An error here probably shouldn't go unreported or unhandled. You may not want to tell the user the error that occurred, but you're probably going to want to ask them to provide some alternative source of data by showing the picker again, or by, I think I've seen some applications, for example, recent files say, I couldn't find that file, should we take it out of the list? So there's no unexpected side effects of those errors. Another important thing here is don't hold open a reference to a URI read closer or a URI write closer, just like it would be a bad idea to hold open an os.file. These are resource pointers into the data stream, wherever it's coming from. And whether it's a local file, a remote resource, or something in between, you're going to be holding an operating system resource there. And if your application does so for too long, particularly if it heads into the background, the system might decide that you're not allowed access anymore, and you could get an error midstream, which is not something that we want. So remember, if you want to store, to use the URI inside that instead. You can access it using that URI function, and you can then persist it as its string identifier for use later. I'm going to say it one more time, always close these read closers and write closers. It's very important. You free up the resources, you make sure that you're being a good citizen on the operating system. Just one additional anecdote here is that on some platforms you may find that if you don't close these, then you have extended your permission to access file system resources longer than is actually allowed, and in some extreme cases, the operating system, such as iOS, may decide to terminate your application rather than risk the resource leak further down the road. So make sure to close them. I find that using defer when you make the request, the function called back, check for the error. If the error is not nil, handle it. And then if the returned URI read closer or write closer is not nil, defer close and then perform the operations that you wanted to. If you're able to do that, you'll probably miss far fewer close operations that really should be happening. So there we go. That is how to handle file I/O resource management in a way that is cross-platform, that engages the user through dialogues when appropriate, and also manages to connect directly to known resources or previously accessed URIs if the user interaction is not the way to go. I hope that was really useful. It took a long time to get to the API that you saw. We went through various iterations, and I hope you understand that really using os.file wasn't possible for what we're trying to achieve, but what we've got is very close in the way that it functions, and you can often drop a URI read closer or URI write closer in place of a file handle into many of these operations. So you should still make good reuse of your code.